right, so we have covered several different ways to factor. Not quite all of these yet, but we're going to have one on hold and look for things. So when we're factoring, the first strategy we should always look for is see if they have something in common. Factor out their GCF. So that's what's at the top of this. That's why this is at the top. That's always going to be the first thing to do. After we factor with GCF, then we're going to follow this flow chart. If there's only two terms, then it's going to be likely to be a difference of squares pattern. So that's what we just talked about. And that's when, for instance, these are both perfect squares with a minus in the middle. So x squared minus 64, that would be x minus 8 and x plus 8. And I think I'm going to make this a little bigger. So put you on pause. All right, so I've been sitting here talking to myself. We'll go back over that. So that second problem has two terms. It was not immediately a difference of squares. What I did, I looked at this. This is in your notes. That 18m squared n minus 2n cubed. They have a 2n in common. That's their GCF. When I take that out, we get 9m squared minus n squared. Then that part inside that big parentheses, now that is actually a difference of squares. So then I've broken that down using our normal difference of squares pattern, 3m plus n and 3m minus n. That 2n that was the greatest common factor is still part of our final answer. And we'll do some more like that, but this is just going to be kind of a reference page that you can look back at. And that we'll finish filling in on Monday. So down here are trinomials. The one on the right, we're going to save this one. The difference is this has a number in front of the x squared. And so we're going to save that for next time. A number that doesn't go away with a GCF, I should preface that. So what we're going to look at here is this one where it says x squared plus bx plus c. So where we've got the x squared, we've got some number times x in the middle, and then we have a number at the end. And remember, our strategy here is we know we need to find factors of c. That means things that multiply to be c, c being the last number. So the 42 is the c, but they have to add up to b. And remember, when we say add, if the signs are different, the number parts are really subtracting. It may be easier to think of it as subtraction. So two sets of parentheses. They each get an x, so that we get that x squared, 1 plus, 1 minus, and then I need to think what multiplies to be 42. So I need two factors of 42, and they're different, so they actually subtract to make this 1 in the middle. So let's think 42, we've got 1 and 42, 2 times 21, 3. Now, you might not know 3 times what, so you grab a calculator and do 42 divided by 3. Oh, 14. Now, notice I've kept going because if I subtract 1 and 42, I do not get 1. If I subtract 2 and 21, I don't get 1. Same for 3 and 14. Does 4 go evenly into 42? Nope. so it is not a factor. Does 5 go evenly into 42? Nope, it's not a factor. Does 6 go evenly into 42? It does. 6 times 7. And some of you may have just click, 6 times 7 came to you as soon as you saw 42, and you're like on to the next problem. That's awesome. But if you get stuck, that's the kind of strategy you want to use. Be systematic. So 6 and 7, and then remember when the signs are different, the bigger number needs to match the middle. So the 6 is going to go with the plus, and the 7 with the minus, so that the bigger number matches the middle. So the bottom one, remember that we are supposed to do GCF first. So GCF first. I look at all those. I see they're all even numbers. So my GCF is a 2. And then inside some parentheses, one big parenthesis first. We're just dividing everything by 2 and see what's left. Now we're going to factor that. All right, we don't need to try to do too much at once. Writing that down so you can see, oh, I need two things that multiply to be 25 and add up to be 10. So the 2 is still out here. W, and that would be a plus 5 and another plus 5. And since they are the same, we could write it as 2 on the outside, W plus 5 with a square on the outside. It's okay to leave it in just 2 sets of parentheses as far as for our class. Just know that is the shortest way to write it, is with the square on the outside. I didn't factor more, I just wrote it in a little bit shorter way. So the one at the right where it says asterisk, so first when I look at that, it does have a GCF. 3 goes into everything. But what's going to be different here is after we divide everything by 3, I still have a 10x squared. And that's not a perfect square, and so that's what we're going to learn how to deal with on Monday, is how to deal with when there's a number in front of the x squared that we can't get rid of with GCF, and it's not a perfect square. So the other one we're going to fill in on this chart is our grouping problem. So there on the far right, you have one that has 4 terms. It does not all have something in common, so there's not a GCF first. But there are some terms that we can factor by splitting it up into 2 groups. So looking at the first 2, what do they have in common? A squared. So if I divide the first 2 by a squared, that gives me what's inside the parentheses, which would be 2a minus b. Then I look at the second 2. What do they have in common? Oh, you say they have a 5 in common. So plus 5, and then when I divide by 5, I get 2a minus b. And then I do my celebration dance because I'm happy that my parentheses match. Then I rewrite things, pulling what's on the outside together into its own set of parentheses, at which point the 2 parentheses that matched, now that only needs to be written once. So this is just kind of a little reminder sheet. We'll fill in that other one on Monday, but a little reminder sheet about different types of factoring. And how to use GCF along with another type of factoring, using GCF as just the first step. So what we're going to look at next is here in your, I'm going to have to turn my page though. All right, so here we go. So these are some problems. This is in your notes, right past that chart page. And we know from the chart and from our experience earlier today, usually when we have two parts, we're looking for difference of squares. But if I take the square root of 20, it's a hot mess, right? It's not a perfect square. So I need to look to see, can I take something out of these two? Do they have a common factor? And 20 and 125 both end in a 5 or 0, so they are divisible by 5. So their common factor is 5. So I'm dividing them both by 5. That leaves me with 4p squared minus 25. That 5 is going to be part of my final answer. So I'm going to just go ahead and bring it down so I don't forget about it. Then the 4p squared minus 25. Now that is the difference of squares. Those are both perfect squares. So 2p and 2p, and then we're going to have a plus 5 and a minus 5. And remember, you can use square root. Now, if you try doing square root and it's a decimal, then that means it wasn't a perfect square. And either it doesn't factor that way, or you need to take out a common factor first, like we took out the 5 first. So, same thing on number 12. On number 12, we need to find the biggest number that divides into 32 and 18, which isn't all that big, right? It's just a 2. And then also notice this time the 18 has an x. So their greatest common factor is not just 2, it's 2x. So that 2x, that's the greatest common factor, is going to be on the outside. Divide by that would be 16x squared minus 9. No x, right? Because those x's would cancel out. 2x stays on the outside. 2 sets of parentheses. Remember, anytime you can always pause me and then presto, do it yourself and check your answer. So 16x squared, square root of that's 4x, and the square root of 9 is of course 3, 1 plus, 1 minus, and that 2x is part of our answer. That 2x, that was our common factor, is part of our answer. My problem, I apparently was writing uphill. Okay, so very similar process for 13 and 14. Take out the GCF first. So here, I'll take out a 3. Three is going to stay on the outside. And then we need to take our square roots. Remember, when it's difference of squares, my 2 sets of parentheses are going to look the same, except the sign. All right? Hopefully, so far, so good. So it's just combining 2 things that you've already learned. Difference of squares and GCF. So let's head down here a little bit. You see whoa, there's some big numbers. So first off, number 15 is a much easier problem than it kind of throws people off. It has 2 parts, but it is not a difference of squares. First off, 9k, that's not a square. And secondly, it's not a difference. It doesn't have a minus in the middle. But we do have something in common. They both have a k. And then that just leaves me with k plus 9. And that's just done in this case. Don't try to make life harder than it is. Okay, number 16, only you just go straight to your two sets of parentheses. You're looking for two numbers that would multiply to be that 48, subtract to be 2. You're going to have a plus and a minus. Sometimes students like to use a little organizer. I didn't show you this yesterday because I don't usually use it, but call it like an X factor. Find your X factors. So what multiplies to be negative 48 and adds to be negative 2? Well, there'd have to be 1 plus and 1 minus because they're different. And then this would be, and the minus has to be bigger, so this would be the negative 8 and the positive 6. And then this is, it's not x though, how about a plus 6 and a minus 8. So this x is not something you have to make by any means. You guys were doing awesome on these kind of problems before and you weren't making that. It's just a way, sometimes people like to do that to kind of organize their thoughts. When we do those problems on Monday, we're going to use something that looks a little bit similar to this, but has a line through the middle. So, I know you're getting curious, right? So, let's see, this whole 168, this looks crazy. Well, let's try if we can get rid of that 3 in front of the a squared. You might say, does 3 go into 168? Well, here's an easy way you can tell. If you add the digits together, 1 plus 6 plus 8, that's 7 plus 8 is 15. Since 3 goes into 15, 3 does go into 168. That's the divisibility rule for 3. You could also just test it on a calculator. So we're taking everything divided by 3. So I get a squared plus a. And when I divide 168 by 3, negative 168, I get negative 56. So GCF stays part of our answer. Two sets of parentheses. Each one gets an A. 1 plus, 1 minus. So then what multiplies to be 56 and subtracts to be 1? Now you could make a list, but if you know your multiplication facts, you are probably shouting 8 and 7, 8 and 7, 8 and 7. If you don't remember that, 1 times 56, then you would test, does 2 go into 56? Your calculator would tell you, yes, 28 times. That's obviously not going to subtract to be 1, though. Does 3 go into 56? No. 1, if you try it in the calculator. 2, 5 plus 6 is 11, and 3 doesn't go into 11. 4 goes into 56 14 times. Nope. 5 doesn't go into 56. 6 doesn't go into 56. 7 and 8. So that's how you would strategically, systematically find the factor pair if you didn't just see it immediately. And I put negatives with those because we know the signs are supposed to be different and we know the bigger number is supposed to be positive. So you have a few there to finish, and then you should see there is something posted on Google Classroom. I know, something new again, but something that looked kind of fun. It's called a quizzes, and you might have had a teacher way cooler than me who gave you a quizzes before. But you can play it like a game. You can do like a flashcard. But I just chose one of them that's about factoring. And I think there's only 10 questions. And then also posted today, if you are in term 2 at least of 2020, I posted instructions for your final project. So that's it. We don't have much more new lessons because we don't have any more days left. 1 week left.